Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of HiveMQ, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Dominik Obermaier, CTO of HiveMQ. HiveMQ helps companies connect devices to the internet by enabling fast, secure, efficient, scalable, and reliable bi-directional movement of data between devices and the cloud. In this talk, we discuss the IoT protocol landscape with a focus on MQTT and the surrounding standards and enabling software. We also explored the critical role of open standards and open source software in creating an efficient and dynamic marketplace that promotes innovation. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research strategy or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you.
Dominik, thanks for joining us on the podcast today.
Yeah, thank you, Eric, for the invitation.
Great. And I love hosting entrepreneurs because it's always interesting to understand how they kind of convince themselves to devote themselves to this journey of starting a company. And Dominik, I think your case is particularly interesting because you've, right out of university, set up a company devoted to protocols, right? And that's that's not the topic I think that most university students are kind of passionately dedicated to. So we'd love to understand a little bit of your background and what was it that kind of that spark that led you to say, hey, I'm going to devote a significant portion of my life to building a business to solve this set of problems.
Yeah, great question. Thank you for that. So yeah, it was not as straightforward, and honestly, also in university, I was not the protocol guy. I did a bachelor in computer science here in Germany, and but I always was working on the side, and so I was exposed to basically some kind of real world applications of technology very early on, and very early on in my career, I had the chance to meet a gentleman called R.L. Nipper, and he designed a communication protocol called MQTT in 1999. And and back then, we can go also into that, but there were a lot of things that came together that led me and also our CEO Christian to the realization, okay, this makes now really, really sense, and we cannot believe nobody else is basically connecting these dots. And then we decided to build a company out of that. And this is how it started, but also happy to dive into more and more details on that.
Yeah, so I think our audience is coming from different places. Some of them are going to know a lot about MQTT and maybe use it every day at work, and others, this is going to be somewhat of a fresh concept. So why don't we do a little bit of the 101 and start with just the question of what is an IoT protocol? How does it differ from a standard? How does it differ from a connectivity technology like NB-IoT? And then we can go from there.
Yeah, absolutely. So one of the interesting things about Internet of Things communication protocols is that, this is nothing particularly new. So if you look at the technologies in the last 40, 50 years, there's something that basically a kind of protocol stack that is used to communicate over the internet. So for example, what most people will know is that there is for example, TCP/IP as a transport communication protocol that is being used. And also chances are, if people are now listening to this podcast, that they're using a kind of underlying internet technology to stream that, for example, IP or UDP and TCP/IP without even knowing. And this is important because computer networks always need this kind of common language to communicate together. And people settle very early on this kind of different communication layers and standardized on that. So for example, and today we see now a Windows machine can use the same internet basically as a Linux machine, Mac OS machine. And because people settled with the same, basically on the kind of communication layer. And in general, like this would be a bit more complicated now, but there is also the OSI model that describes that in detail, how much layers there are. But in general, I think for this conversation, we can say, okay, there's this kind of underlying connectivity technologies that are being used. And then we have this kind of application protocols on top. Because just that you can connect networks doesn't mean that they can understand each other. And one of the best examples is for the Internet of Humans is a protocol called HTTP. So HTTP was also developed in the 90s, basically to access websites or to have a client-server protocol where any client, in most cases a web browser, can go to a server and request a web page. So for example, I could go now to Wikipedia, go to wikipedia.com and look for an article. And my browser would ask over something called HTTP, the Wikipedia server, and the Wikipedia server would respond with an answer and give me the article. So on a very, let's say, high-level concept. And this is great. Basically, this is this kind of request response style protocol. So somebody is requesting data and then a server serves the data. This is how most technologies for the Internet of Humans work. The problem here is now that if we look at Internet of Things, we have a bit of a different problem. So to give a sense of the magnitude of the problem, we now have connected, I think, 60% of all people on Earth. So let's say, for the sake of conversation, 6 billion people almost are connected to the internet. 5 to 6 billion people. Depending on which kind of analysis you read, we have approximately 40 or even more billion devices connected to the internet. So we have almost 10 times the amount of devices using the same internet technologies as humans. And it's pretty clear that technologies built for the Internet of Humans is not suited for the Internet of Things. Because if you think about it, devices, which could be fridges, factories, cars, and really anything you can connect to the internet, they are constantly producing data and constantly need to receive data. And so you have almost this kind of streaming approach where the devices don't request data, but they produce data anytime and they need to receive data anytime. And this also in a very, very fast way. And also there are other things like, especially if you have mobile networks in the mix, this means you have high latency, so it takes a long time for data packets to be transmitted. And also the bandwidth is not so good. So I'm now connected with my computer to you, and now the bandwidth is pretty good. So we can communicate very fast. If I drive with a car over a mobile network somewhere in the US or in Europe, like in some remote areas, chances are that the internet connectivity is not so good. And this is why we need dedicated communication protocols that are designed to handle these use cases. And there are some of them, and I'm happy to go into that later, like MQTT and also others. And these are communication protocols exactly designed for the Internet of Things and not designed for the Internet of Humans. And we see that now that there are a lot of surveys, for example, the recent Eclipse developer survey that basically showed that most developers these days working on anything IoT related are using dedicated Internet of Things protocols. And so a lot of people have exposure who are working on these devices. People who have not worked on IoT use cases probably won't have so much exposure to these protocols yet. But this is only a matter of time because Internet of Things is not an industry. It's really something going through all the industries. Some of them are earlier than others.
Okay, great. So that's a great foundation. Let's maybe, we're certainly not going to cover the entire protocol ecosystem, but let's discuss a few of the alternatives to MQTT for communication with devices. And then we can also get into what differentiates them and why have you chosen in particular to focus on building a company to connect via MQTT. But first, what are the other set of protocols that would be in that ecosystem?
Yeah, this is a great question. And there was also in 2014 or so, 15, there was something that people sometimes call the protocol wars, where you had a lot of competing technologies competing for this kind of Internet of Things connectivity. But this time is over. So for quite some time. But there are many, let's say, different protocols used for specific purposes. So back then, there were protocols like XMPP, which comes more from the chat side of things. So Google Chat, for example, used that. Back then, AMQP, which is coming more from the traditional message queuing world, was one of the, I would say, contenders. MQTT as a basically Internet of Things protocol. It was designed from the ground up for doing that. And then, of course, there's also things like HTTP that is being used also for IoT use cases. So I think this would be the ones today. I think you usually only see MQTT, HTTP, and AMQP, but AMQP only for very specialized use cases. And HTTP is usually something that is being done either for some very special use cases or for some, let's say, deployments where the architects were not aware of dedicated IoT protocols like MQTT.
And so I guess folks are familiar with HTTP and to some extent, the evolution of it. So these protocols also evolve in terms of functionality to some extent. What did MQTT look like when it was born in 1999, and then in 2012 when you set your company up, and today? How has the functionality evolved over the past 2 decades?
Yeah, it's a great question. So quick thing I wanted to mention, because also why did we even use MQTT and why did we decide to dedicate the time? So MQTT was developed in 1999 and it was developed for a specific use case for oil pipeline monitoring, basically a SCADA system use case. And Philips 66 back then basically had one of the first TCP modules they used for satellite communication. And one of the issues was that satellite communication, even today, is still pretty expensive compared to other alternatives. And back then, it was even more expensive. And so the designers of the protocol, Andy Stanford Clark, who is CTO at IBM in UK, and Arl Nipper, who is now with a company called CirrusLink, they decided to solve the problem and save a lot of bandwidth, basically over mobile networks, over TCP. And so designed that they asked the question, what is the most lightweight protocol and the fastest protocol we can develop over TCP IP? And also utilizing all the characteristics of TCP IP, that, for example, you have this guaranteed message ordering, it is guaranteed to not lose data and stuff like that. And they built a very thin layer on top of TCP IP and a so-called publish-subscribe layer. MQTT is a publish-subscribe protocol, which completely decouples the producers of data and the consumers of data. Because if you think about it, you do not want to reconfigure all your sensors and actors in the field just because you change something on the server sides, or if you have new producers of data or new consumers of data somewhere in the data center. And so they built this very dynamic protocol where data producers and consumers can enter and leave basically the system at any point of time, which also has they built in some features for remote monitoring, basically, that if a device gets offline for some reason because it's broken, the battery is out and so on, that what is called the MQTT broker, so the message distribution software that is usually residing in the cloud, is aware of that fact and can also then notify other participants, hey, like this sensor is not available anymore, there might be an issue. And so they built some very unique features like that into the protocol. But then unfortunately, this protocol was shelved and it was not used anymore because why? It's proprietary. In 2010, around 2010, IBM decided to open the protocol, make it so-called royalty-free, which means they basically promised to not sue you if you would implement the protocol. And then the first open source software, Mosquito is one of them, open source broker, they were started. And also we started a company because we thought like, hey, this whole MQTT thing, why isn't everybody using that? This exactly solves all the issues we have these days for large-scale deployments. And we figured out, okay, you cannot really use it in enterprise environments. And this is how we started the company, to build software to make it suitable for commercial deployments, where reliability is key. So we developed something called clustering and really made a lot of innovation in the space to fix some of the issues that prohibited companies to use the MQTT technologies in production. Yeah, and then fast forward 2014, we also helped as a company specify the standard. So MQTT is an ISO standard. And we helped specify that with other players like Cisco and others. And in 2018, the version 5, which is the newest version of the protocol, was released. We also helped standardize on that. This is now the protocol used for a majority of devices connected around the world.
Okay, interesting. So would it be correct to say that the fundamental structure has kind of remained the same, but the innovation has been around defining the standards and tailoring them to the needs of the market, and then also building software around MQTT to address some of the challenges inherent in the solution?
So I think the general design of MQTT is still the same. And also the design principles, I think, are today even more important than probably they were back then. Because MQTT has some really, really huge advantages when you want to scale something. So I'll give an example. We have customers that have tens of million devices on a single installation. And for people who are familiar with message queuing technologies, so we have a customer that has more than 150 million so-called topic subscriptions on a single deployment. Traditional message queues usually have around 100, maximum thousands. And with MQTT technologies, you can really scale that very fast and very big in a very dynamic way. So in order, when it comes to the innovation, on the one side, of course, the standardization, but it's also the feature sets, of course, evolved. From you see the same with HTTP. I mean, HTTP is also pretty old, and there were multiple iterations that the protocol remained the same with HTTP, but there were a lot of, let's say, tweaks and more standards, and also some features added. And the same is true for MQTT. So especially version 5 is full of features that the market basically demanded. And some of the proprietary functionality, for example, we in our product, we also help bring back to the standard. So everybody can enjoy that because I believe in open standards. So not everybody using MQTT will be a HiveMQ customer, and it's good to have every standard lives by multiple implementations and having them available. And so I believe it's the best approach is not to rely on proprietary functionality, but bring back things into this standard, so everybody in the market can participate on the feature sets and not only people using a specific implementation.
Yeah, great. Yeah, I'd love to get into the topic of open source, but before we go there, let's touch a bit on maybe we could say the verticals and the horizontals. So, IoT is a very broad topic, pretty much, as you mentioned. Every industry, healthcare, transportation, manufacturing, et cetera, is using IoT data to some extent and devices. And they each have their own regulatory environment. They each have their own kind of requirements. And then within those industries, obviously, there's heavy use cases that require very high volumes of data. There's use cases that require putting a sensor out in the field and kind of letting it sit there for 10 years and send one piece of data every 30 minutes. So you have also a wide variety of uses in every industry. So in this very diverse landscape, how do you define what is the right messaging or communication protocol for a particular use case? How do you make that determination?
Yeah. So the answer very often is here, as always, is it depends. And it depends on multiple things. So for example, when we come to different verticals, what you see across most verticals is as soon as you have internet connectivity, MQTT is the dominant protocol to use. For MQTT is really designed for internet communication. It's super lightweight. It's extremely fast. It relies on the underlying communication technologies like TCP/IP, which very often have very efficient implementations, also over the mobile network, for example. So this is one thing. MQTT, as a mental framework, MQTT is usually used when there's internet connectivity, and these days also very often in things like factories or where you have multiple data producers and consumers. So these days we do a lot of work with factories where they have, on the one side, autonomous factories that cannot rely on an internet connection. And so they build an MQTT system in the factory, which is almost a central communication bus. And then they also add another MQTT layer for communicating to the cloud. The thing is, you don't see MQTT alone usually in a factory, for example. And every industry has their own set of protocols. So in factories, you often, for example, see things like OPC UA. You see also Modbus and a lot of other legacy technology. And what you often find is that there is a kind of bridge happening. So to bridge the old world and the old legacy protocols to an MQTT layer. And this is what you see with many of let's say, the large companies and corporations these days. And we have multiple customers in the US where they have almost 100 factories around the globe, and they now connect everything with the same technology with MQTT, and they get real-time insights into everything what's happening globally. And this is something you can do when bringing IoT protocols also to domains and have the advantages of that. You also see this in transportation, for example. So you see MQTT being used also inside vehicles, complex vehicles, but also for cloud connectivity. But of course, still you usually have the old world. And this is why you usually bridge MQTT technologies with others.
Okay. Thank you, Claire. Well, let's discuss open source now, and maybe it's less interesting the question why is open source important, but maybe more interesting why is it important to HiveMQ? So why have you as CTO of a company decided to also devote your time and effort to supporting the Oasis initiative, and how does open source interface with your business?
Yeah. So I would like, in this case, I would quickly like to differentiate between also open standards and open source. So here at HiveMQ, we believe in both. So open standards, from my perspective, are the absolute foundation for any communication technology. And to make it short, the history of the internet showed that open standards are required for any kind of connectivity. All the proprietary protocols went away, even if you had companies like Microsoft pushing for that. So for me, it's clear any kind of communication technology must be open standards. This is why I'm actually a bit unhappy that many companies are these days trying to make a proprietary version of open source, of open standards. This is a bit sad. So you see that with the big cloud vendors. So you have MQTT support, for example, with Microsoft and with AWS, for example. But the reality is that they don't really support MQTT to the full extent, the full open specification. So customers don't get the full experience and get a proprietary version of that, which you usually don't see with a lot of vendors, but especially the big vendors usually do that because this creates a kind of lock-in effect. So I do not believe that communication protocols should be used for lock-ins. So I'm a heavy advocate for open standards and specifications. So I dedicate a lot of my time for working on these open standards, because I believe this is the only thing that brings the industry forward. When it comes to open source, which means HiveMQ, for example, has an open source version. So most of the standard MQTT functionality is available for free on the server side, but also on the client sides. And we earn our money with customers who have mission critical use cases. So really the factories that cannot have a downtime, they're connected car scenarios where they have millions of customers who rely on a good user experience, things like that. So we are doing really the mission critical things. And especially for startups and other companies who are not having the budget for doing mission critical deployments, of course, open source software is good. Open source software is free. And also there's a community around it. And especially, let me add one thing here also in addition. When it comes to communication protocols, I also believe that especially the client implementations need to be open source. So we are heavy sponsors also of the Eclipse PAHO project, where we sponsor the maintainers for maintaining free and open source Apache 2 license and Eclipse licensed implementations that customers can use for putting things into a car, into a fridge, into a backend software, and so on, to communicate with MQTT. And all of that is completely free and open source. And we are investing into that because we believe in growing the pie for everybody is, for us as a company, the right move. And and really supporting the whole ecosystem, because we don't care if somebody wants to use another MQTT software with that client. Absolutely, I do not believe communications protocol should lock you into one vendor. The decision for a vendor in the cloud should really rely on what's needed for the business. But we are not fans of locking customers or users into a specific piece of software. I think these times are actually over. And in 2022, I don't think this is the right approach. The approach is really customers should have the freedom of choice, should use MQTT technologies, and should choose the vendor on the cloud and on the backend side they want to use that serves them best.
Yeah. Well, I hope you're right. That is the path forward. Obviously, larger players always have some kind of incentive to lock the ecosystem into kind of a status quo. But it does sound like from the end customer side also, there's a lot of push towards open standards. So hopefully that that wins the day. Let's discuss then your solution. So I think we've already covered the business, the value proposition to an extent in terms of supporting mission critical use cases that have to scale across thousands or millions of devices in kind of fast, secure, efficient, scalable. But let's then look at what are you actually providing in terms of your flagship product and then the other solutions in your portfolio.
So our flagship product is the HiveMQ MQTT platform. And this is basically a technology component called, this is an MQTT broker, which is a data distribution software designed for mission critical use cases. So we have customers all around the globe, like BMW, like Audi on the automotive side. We also have the largest logistics companies in the world as customers, who are relying basically on delivering the packages to their end customers with our technologies. We have airports as customers who basically rely on smooth operations. And so these customers, they need mission critical software that runs all the time, that also scales with their needs, because very often we see that they start smaller and then they roll it out across the whole company. And so this is what we're focusing on. And our MQTT platform is like to this day the most scalable version of anything. So we've shown that we can scale to more than 100 million devices with a single installation. And we have customers from all industries. Also, for example, Netflix is also a customer of ours, which I can talk publicly about. And they use all of that for making sure the business just runs. They don't, it's similar with a database. You don't want to care about it. It just needs to work. But the scale we're operating is usually very high. And this is why we have built, I think we were honestly the first to market back then when we brought in elastic clustering to the market, which means you can add and remove basically data nodes at runtime as you wish. So for example, you can scale up and scale down you want. We focus on security. This is a huge part of what we do. Reliability is our core business. But also we brought in a lot of innovation to the market, for example, around observability, which means if you have thousands or even millions of devices, it's a pretty hard problem to identify which of these devices are having issues. And so we provide also technologies for identifying issues and fix them before basically the end customer has detects an issue and things like that. So it's really about the making MQTT technology ready for the enterprise. So besides our enterprise platform, which consists of the broker and multiple additional modules like AWS Kinesis integration, Event Hubs integration, Kafka integration, and a lot of other different things. We also have what we call HiveMQ Swarm, which is a quality assurance and load testing tool that allows our customers to continuously monitor how is their performance, how are their deployments doing, how are their backends doing, and also you can do rollout simulations. And customers use that, for example, if they enter a new market, for example, automotive companies entering a new market, and they want to test their end-to-end system, like, does it really scale? If we add, 10 million additional users to our systems, does the broker still work? Does it have enough resources? But also, are our backend services, our microservices working still correctly in the cloud? Is our databases we use, are they sized sufficiently? And things like that. So we can basically make it easier for our customers to understand the impact of the decisions they make, and also they can see how is the whole system, not HiveMQ, but the whole system they're building scaling. And then we have a lot of additional tools, like, for example, running things on Kubernetes in the cloud and so on. And we are constantly working on new innovations we bring to market.
Let me see if I can get you to visualize this for me using a few examples. So if we look at three different hypothetical customers, let's say one is Netflix, which is primarily streaming content, streaming video. Then we have the second hypothetical customer would be Volkswagen. We have fleets of vehicles, kind of mission critical, real-time communication, et cetera. And then we have, let's say, Total managing oil and gas infrastructure of remote regions. So three different customers, different scenarios. Would they be using the same toolkit entirely from HiveMQ, or would they be using your solutions in different ways?
No, actually, they would use it in the same way. I think the main features, functionality they would rely on would be a bit different. So, for example, such a hypothetical streaming example would probably require a lot of bandwidth. Not so many users compared, for example, to connected cars. So, but still, like a lot of users, elastic scalability, because you need to scale the system up and down in order to save costs. This is something you would rely on, but you would also rely on a lot of message throughput. So you would really focus on the reliability of the solution. Connected car is also then an interesting one. So you would you have the scalability aspect of that. So you can, as soon as you add more users, you sell more cars. of course, your user base would grow. And you would also very likely, in these examples, use the extension systems to integrate with your own enterprise systems. Automotive companies have very complicated backend systems usually. And so you probably would use the open source extension system to integrate with these custom security systems and so on, and basically hook the software in. For our oil and gas use case and also asset monitoring use case, it's not like you would add millions of new devices per year or so. Here you would focus on the reliable throughput of data and also the reliability aspects of that. So overall, the installation would look pretty much the same. So it could be either hosted in our cloud or hosted on their own clouds. But the details of the platform, what you would be using, would be a bit different. Also, the USPs would be a bit different for the different customers. But overall, it's the same software. All of them would benefit from new modules we release, would benefit from new integrations and new feature sets.
Okay. And if we look at the business model behind HiveMQ, so I guess we have a few different variables. We have number of devices, we have volume of messages, we have volume of data across those messages. There's probably other things. We don't have to get kind of too much into the details there, but what would the pricing model be? Is this kind of a standardized equation, or do you look at each customer and say, let's figure out something that makes sense given your unique situation?
So what we have is we have our cloud offering that is that many customers start with that. So this is actually completely free up to 100 devices, which is for some use cases even sufficient, and has a pay-per-use model that is usually good until, let's say, 1,000 or 10,000 devices. Above that, this really doesn't make so much sense because pay-per-use models, you see this also with public clouds, they work very well if you have low volume, but in a mission-critical production case, usually this is getting honestly more expensive at some point of time, and another approach would be better. So we have basically this is also per industry. So for example, as I try to outline in a connected car platform, you have millions of devices, and the customers usually think a bit different because it's basically a cost model per car, a per device calculation. While if you're in a factory, you usually have a handful or hundreds of devices, not millions of devices, and the value unlocked here is totally dependent on the reliability. And it's basically the cost. It's basically about the mean time between failures and the mean time to recover. This is how the value is usually perceived, and this is why we have multiple editions for multiple industries also that are really tailored to the industry needs. So to have really the most effective, basically pricing model for all of them. But for people who just want to get started, we have our cloud model that is just pay per use, and you pay at the end of the day per connection in our cloud. But for mission critical use cases, we have tailored versions for all the industries to serve them best.
Okay, great. Yeah, sounds like a very pragmatic approach. Well, Dominik, this must be an exciting time for you. I think you were kind of in the IoT game since 2012. And back then, I know the question was very much, what is IoT? And now we're getting to the point where basically every company is using it to some degree and often in fairly high volumes. And we're kind of getting to that hockey stick or at least sustained high level growth. So if we look at your business, what is it that excites you about the future? Obviously, you have a mature platform today. Looking forward 3 years, 5 years, 10 years, where do you see HiveMQ growing?
Yeah, so at HiveMQ, we're building the central nervous system for our world. And eventually, we believe we will help connect every device on Earth. And with our software we build, be it on the open source side, be it on the client side, be it on the server side. And for me, it's really crazy how things have developed. So back then, it was a vision, and honestly, a bit of a crazy vision sometimes. And now we really see that things are starting. But everything around IoT, it's still day one. It's just so crazy. And I speak to so many developers also in conferences. While I live in the IoT bubble now for quite some time, one could have the impression, yes, IoT is really now here, but it's not even there yet. Some industries are starting it. And when the customers we work with, what they are building and what they are going to release in the next 3 years to the market, this is just crazy. And what I like most about my job is there's really no way that I can be a pessimist, because seeing what our customers are working on, the hard problems our customers are tackling, I mean, this is why I'm a massive optimist. This is just crazy what companies do these days. And also, I'm a bit humbled to see what our platform, what our technology can enable them. And it's not only about saving costs. I mean, very often there's a cost saving, but it's about customers can do things they couldn't do before. And they can serve their customers better. And this excites me every day. And this is what IoT is for me is about. IoT is for me, this might be a longer conversation, but IoT is not really for me not an industry. It's really a kind of an aspect that will transform everything we do as humans over time. And we're building the central backbone and the central nervous system for that.
Yeah, that's a good way to think about it. When it's a little bit like how do you talk about the internet, right? The internet is not really a technology. It is, it's a thing that exists and influences many, many different industries and businesses and has many different applications. And IoT is just kind of bringing that thing to the rest of the world.
Yes.
But when I set my business up a few years after yours in 2016, but I think it was with a similar mentality that this is going to be just an exciting set of challenges to solve for the next, 10, 20, 30, 40, 50 years. As long as you want to keep playing in the space, there will be new challenges to face. And and certainly, as you said, we're still in the opening stretch here. Dominik, I think we've covered a good bit of territory here. Wrapping up, any other things that are important for folks to know?
I think we covered most of that so far. So especially for people who haven't heard about MQTT. MQTT is, so the best way is really to Google MQTT. So we have, for people who really want to get their feet wet with the technology, we have at HiveMQ a 10-piece blog post series that many people use to get started with MQTT. We have a YouTube channel and also a series where I try to explain also the core concept in a more digestible 3 to 5 minute format to developers and architects. And for the people who are basically owning parts of a business and who want to learn more about how can technologies like MQTT help them get more effective, save costs, and also do things they couldn't do before. So we also have a lot of white papers, a lot of customer use cases also on our website. So I invite people to look at that. And also I'm always up for a chat. So people can feel free to connect over LinkedIn, drop me a message. I'm always happy to help and share thoughts with people.
Awesome. Dominik, thanks for your time today.
Thank you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.